Okay, on this worksheet, in this lesson, we're going to talk about different kinds of counting problems and how to solve different situations. Before we start talking about the counting problems, I want to go over a couple buttons on the calculator real quick. So if you hit your math button and you arrow over to probability, which is where we're going to be at today, this second button is what I'm going to use when we have an arrangement and we're talking about permutations. This third button is what I'm going to use when we have a combination problem and a problem about committees. So I'm going to use the NPR for permutations without repeating, and I'm going to use the NCR button when I'm talking about combinations and committees. Okay, so here we go. The first thing we're going to talk about is a simple principle called the multiplication principle of counting rule. And this simply says, if a task consists of a sequence of choices in which there are P selections for the first choice and Q selections for the second choice and R selections for the third choice and so on, then the selection can be done by multiplying P times Q times R. So, for instance, here would be example 1. If I wanted to know how many different meals could be ordered if I had 2 appetizers, a soup and a salad, if I had 4 entrees to choose from, baked chicken, steak, hamburger, or spaghetti, and then I get to choose a dessert, and I have 2 choices, ice cream or cheesecake. There could be several combinations. I could have soup, spaghetti, cheesecake. I could have soup, chicken, cheesecake. I could have salad, chicken, cheesecake, and so on and so on. Instead of listing every single one of them to find out the number, I could simply take the number of choices I have for appetizers, the number of choices I have for meals, and the number of choices I have for desserts, and simply multiply them. So 2 times 4 is 8, and 8 times 2 is 16. So if there are 2 appetizers, 4 entrees, and 2 desserts, there are 16 possible meals that I could order. The next thing we're going to look at is permutations. And when I say permutations, we're always talking about the arrangement of our objects chosen from N objects. So this is the total number you're choosing from, and this is the number that you're going to pick. So there are 3 types of permutations we're going to look at. We're going to look at distinct with repetition, without repetition, and then we're going to look at what happens when it's not distinct at all. So distinct with repetition is where we'll start. Excuse me. So something is distinct. That means that they're different. Like the letters of the alphabet, that's 26 distinct choices because they're all different. A is different from B, is different from C, is different from D. So we're going to look at distinct with repetition. So repetition is going to be allowed. So I could choose A a bunch of times, I could choose B a bunch of times, I could choose C a bunch of times, and so on. So if you have distinct with repetition, the rule that we're going to use is you're going to take N to the R power. So here's an example. This will be example number 2 on the worksheet. The International Airline Transportation Association assigns 3-letter codes to represent airport locations. For example, Bush Intercontinental uses the 3 letters I, A, and H. So that's 3 letters, I, A, and H. Fort Lauderdale, Florida uses 3 letters F, L, and L. Notice repetition is permitted. You can see that right here because I used L twice. How many different codes are possible? So if I want to figure out the total number of codes possible, I know that I'm going to be choosing 3 different letters. I know if I'm thinking about the alphabet, there are 26 letters I could choose from for the first slot. Since I can repeat, I still have 26 to choose from for the second slot. And I have 26 to choose from for the third slot. So it's simply 26 times 26 times 26, or we could write this as 26 raised to the 3rd power. So there are 26 letters in the alphabet, and I'm going to pick out 3 of them. So we type that in our calculator, 26 raised to the 3rd. So I'll pull my calculator, 26 raised to the 3rd, and we get 17,576 different codes that I could have. The next thing we're going to look at is when you have distinct without repetition. So N objects are distinct. Again, if they're different, the alphabet is a good one to look at because, again, A is different from B, is different from C, and so on. But this time, we're going to say repetition is not allowed. So once I use the letter A, I can't use it again. So if you have distinct objects and repetition is not allowed, then we actually get to use this button in the calculator if we want. We can do it with it, we can do it without it. Alright, so here's an example. This time we're going to do a code. It's going to be 3 letters again. We're still going to use the alphabet, but no letter may be used more than once. And they want to know how many different codes. So again, we're going to have 3 letters we're going to choose out of 26. The first time I choose a letter, I can choose any letter. So A, B, C, D, E, F, G, all the way to Z. I have 26 choices. Now that I have a letter and I can't repeat, I don't have 26 choices anymore. Now I only have 25 choices. And to get my last spot, I don't have 26 to choose from because I've already used that letter and I'm not repeating. I don't have 25 because I've used that letter and I'm not repeating, which means now I have 24 letters to pick from. So I could simply multiply those together and do 26 times 25 times 24. So 26 times 25 times 24, and we get 15,600 different arrangements. Another way of doing this is using our PNR button in the calculator. Remember, N is the total number that you get to choose from, like your bag of marbles. So my bag of letters. So there are 26 letters in there, and I'm choosing how many out. I'm choosing out 3. So your R is equal to 3. The total you have to choose from and how many you're going to choose. So we're going to go use that button in our calculator. I should get the exact same answer. So when you type it in the calculator, you type in the N first, so 26. Then I'm going to type in the math button. Go over to probability. I'm using the NPR button. So my N was 26. I'm going to find the permutations for R, which is 3. And again, I get 15,600. You don't have to use this button. You can simply multiply 26 times 25 times 24. This is just if you want to use the button. Okay, let's go look at another one. This time, on this example, they want to know how many ways can 5 people be lined up. Well, if you're lining people up, you can't repeat, because once someone's in line, they can't be in a second place in line. So this time, I've got 5 slots to fill. And the first time I'm deciding who's going to go in the first spot in the line, there are 5 people I could choose from. Now that that person's in line, I have 4 people to choose from. And then 3, and then 2, and then 1. So 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. So there are 120 different ways, different arrangements I could line 5 people up in order. Or we can do the permutation. So how many people did I have to choose from to start with? 5. And then I want to know how many people, how many slots I had to fill. Well, 5 people. So I'm going to go type this in my calculator. So 5, math, over to probability. The second one, 5. So 5 total people to choose from. And then I had to put 5 people in line. So again, I got 120. The last one we're going to look at is a birthday problem. Example 5. It says Shannon, Patrick, and Ryan have different birthdays. How many possible ways could this occur? Assume there are 365 days in a year. Okay, so we'll do it without the button first. So person number 1, there are 365 days that I could have for the birthday. Birthday number 2, right here it says different. So that means whatever this birthday was, this person can't have. So now I only have 364 dates to choose from. And again, this last person, Ryan's birthday, it can't be the same as Shannon's and it can't be the same as Patrick's. So now I only have 363 days to choose from. So I could simply multiply those 3 together, or I could go do the permutation. Remember, N is the total number of birthdays in the bag. Well, there are 365 birthdays to choose from, and R is the number of birthdays I'm going to pull out of the bag. So I have Shannon, Patrick, and Ryan. So it'd be 3. So let's use the shortcut this time. So I'm going to go type in 365, math, probability, and I have 3 I'm going to choose. Ooh, that's a big number. 4, 8, 2, 2, 8, 1, 8, 0. There we go. That's the number of different birthdays I could have, and they wouldn't repeat. Number 3. This is the last case, and it says if n objects are not distinct, and we use all of them in the arrangement, the number of ordered arrangements is equal to n factorial divided by n1 times n2 times n3 times n to the k, where n is equal to n1 plus n2 plus nk. And I don't have an example for that one. So we talked about the counting principle, we talked about permutation. Now we're going to talk about combinations. So when you see the word combinations, we're going to think about this button in the calculator. And when we see the word combinations, order's not important. So it doesn't matter which one I put first, second, or third. And anytime you see the word committee, it usually means that you're going to use a combination. Excuse me. So let's practice this button in the calculator too, like we did the other one. Okay, so it says C31. So we're going to type in the 3 first, and then we're going to hit math for probability, and we're going to go to the third one this time, and it was 3-1, so then I type in the 1. So it tells me 3 combinations is what I can have. Let's do it again. So this time they want me to do 6 and 3, and there are 20 combinations. And the last one they want me to do is 52 and 5. So if I have 52 things total, and I'm choosing 5 different things out, the number of combinations, 2, 5, 9, 8, 9, 6, 0. There we go. So that's just some button pushing in the calculator to make sure that we understand. So I'm asking you about a combination or a committee. N is the distinct objects taking R at a time. So there are 3 objects, and I'm going to take 1 at a time. There are 3 combinations. There are 6 objects, and I'm going to take 3 at a time. There are 20 combinations. If I have 52 objects and I take 5 at a time, there are several combinations. All right, here we go. So when they give you a word problem where they're asking you to find a committee, because how many different committees of 3 people can be formed from a pool of 7? So this is your total right here, and the number of people that are going to be in the committee, that's your R. So they want to know 7 combinations. Total of 7. I'm pulling out 3. How many combinations can I have? So 7, probability, number 3, and 3. So there are 35 different combinations that I could put together for the committee. In how many ways can a committee consisting of 2 faculty members and 3 students be formed if there are 6 faculty members, so that's my N, and there are 10 students, that's my second N. So really we're going to have 2 combination problems going on at once. So the first thing I'm going to do is put the faculty together. So I'm going to have 6 faculty members to start with, and I'm going to choose 2 of them. And then I'm going to have 10 students, and I'm going to choose 3 of them. And I'm going to find out which each of these are, and then I'm just going to simply multiply them together. Okay, so we're going to do 6 probability. I'm going to go down to combinations. So 6 people, and I'm going to choose 2. There are 15 ways to do that. Okay, and then I'm going to go do it for this one. I've got 10 students, and I'm going to choose 3 of them, and that gives me 720 combinations. And I'm going to take these 2 numbers, and I'm going to multiply them together. 720 times 15. Let's see. I feel like I typed something in wrong, but oh, I did. I typed the wrong button here. Okay, I gotta try that again. Okay, so 6 probability. Do the third button, 2. So that one I had right. I think I typed this one in wrong. Then we're gonna have 10. Go over to probability. Choose 3. Okay, that makes more sense. 120, not 720. Now I'm going to multiply 15 times 120, and that's going to give me 1,800 different combinations that I could have if I wanted 2 faculty members and 3 students. Alright, so the last thing we're going to look at is forming different words. This is going to work a lot like the one we just did up here. They want to know how many words, real or imaginary, can be formed using all 3 letters in the word rearrange. So the first thing you want to do is figure out if there are any letters that are repeating. So I've got 1 R, 2 R, 3 R. So I have 3 R's. The next letter is E. E has 1, 2, so there are 2 E's. The next letter is A. There are 1, 2, 2 A's. The next letter that I haven't used is N. And there is only 1 N. And the last letter I haven't used is G, and there's only 1 G. Alright, so what we want to do is figure out the number of different 9-letter words I could make. So we're going to start off with, there are 9 total letters to choose from, and I'm going to choose 3 of those to be the R's, because that's how many R's there are. Times, now if I've already used 9 letters, that means, if I have 9 letters and I've already picked out 3 of them, and 3 of them are R's, that means I only have 6 left, because 9 take away 3 is 6. So now, I'm going to have 6 to choose from, 6 letters total, and I know that 2 of them are A's. So I had 9 total. I used 3 of them, so now I have 6. I just used 2 of them, so now I have 4. So I have 4, and 2 of those are E's. So I had 9. I used 3 of them. I have 6. Excuse me. I used 2 of them. I have 4. I used 2 of them, so now I only have 2 left. And there's only 1 N. And I only have 1 letter left. We're going to type this in our calculator and multiply it out. We're going to get 15,120. Excuse me. Alright, so we're going to work a couple problems from the worksheet together. And I'm going to leave some for you to do, and then you're going to take the quiz at the end. Okay, so the first few that we're going to do, not hard at all. We're just going to do some in our calculator real quick. They said find the value of each permutation. So it's just knowing how to use the button. So if you don't have a graphing calculator at home, this is some of the ones you're going to want to do in class. So I type in a 6, I hit math, go over to probability. This is a permutation problem, so I'm going to choose the second one, and then I'm going to type in the 2, and out pops 30. Let's go do one more. So this is a permutation problem because it says P. So I type in the 7, and I go over to math, probability, choose permutations, and it was 7 permutation 2, and 42 pops out. Alright, so I think those are pretty easy, so I'm going to let you finish this section. Notice I got rid of 12 and I got rid of 13. Okay, let's go look at the next problems. 15 through 21. I'm going to take a drink real quick. So in 15 through 21, these say find each combination. So again, this is some more calculator stuff. So we're going to use the combination button this time. Excuse me. I didn't mean to get rid of 13 up here. I'm going to get rid of number 11. I want you to go ahead and do 13 and do 9. My fault. Do 13 and 9. Okay, on 15, you're going to type in the first number 8, math, probability, number 3, 2. It tells me there are 28 combinations. Okay, let's go look at number 16, same kind of thing. I'm going to have 8, math, probability, go down and choose the combinations of 6, and I find out that I still have 28. And it's okay to get the same answers. And I'm going to let you do 17 and 19, and I really am going to get rid of 20 and 21 this time. Okay, so far, I did 7, 8. You're going to go do 9 and 13. I did 15, 16. You're going to go do 17 and 19. On 23, I'm going to change the directions a little bit. instead of going and finding or listing the order, what we're going to do instead is just find out how many. So instead of listing all the ordered arrangements, I want to know how many. How many arrangements. And anytime I'm asking about how many arrangements, we're talking about permutations. So they tell me that I've got 5 objects, that's my N, and I'm going to choose 3 at a time, so that's my R. So we're going to go do exactly what we did on 7 through 13. We're going to go type this in our calculator. So I'm going to have 5 that I just started objects, and I want to find the possible arrangements if I choose 3 at a time. So 5, math, permutation of choosing 3. The answer is 60. And that's why I didn't want to list them. I didn't want to list 60 things. I just wanted to know how many. Okay? Okay, I'm going to let you go do number 25 the exact same way. So again, it says list, but I don't want you to list. I just want you to find how many ordered arrangements. So just find the amount. Okay? Number 20 says list all the combinations. So this time it says combinations. 25 said arrangements. Arrangements means permutation. Combinations, that's my C. And again, I don't want you to list them. I want to know how many. I want to know how many combinations of 5 objects are taken 3 at a time. So we're going to do 5 objects. I want to know how many combinations if I take them 3 at a time. So I go to my calculator again, 5 objects, taken 3 at a time. I have 10 combinations. Okay, and I'm going to let you do 29. So you're going to do 25, you're going to do 29. Again, we're not going to list them. I just want to know how many. Okay? All right, so now let's go look at 31. 31 says that shirts and ties problem. A man has 5 shirts and 3 ties. How many different shirts and tie arrangements can he wear? So this is just that counting problem that we did at the very beginning, just like we did with the menu. So I'm just going to take the total possibilities we have here, the total possibilities we have here. So I have 5 shirts times 3 ties. I have 15 different arrangements that we could wear. Okay, I'm going to go look at 35 with you. I'm going to let you do 33. On 35, it says forming numbers. How many 3-digit numbers can be formed using the digits 0 and 1? Repeated digits are allowed. So I want a 3-digit number, 1, 2, 3 digits, and I can use 0 and 1 only. So I have 2 choices for this. It can be 0, 1. I have 2 choices here. It could be 0, 1. And I have 2 choices here. It could be 0, 1. So I have 2 times 2 times 2, which is 2 to the 3rd, which is equal to 8. I have 8 different arrangements. All right, 37, we did one just like this in our notes, so I'm going to let you go do 37 for homework. You have an example on the front. Let's go look at 39. How many different 3-letter codes are there if only letters A, B, C, D, and E can be used, and no letter can be used more than once? Okay, so this is going to be a permutation, and it's a permutation that doesn't repeat. So I'm going to do this the long way first. It is a 3-letter code, so 1, 2, 3. So that's my R. And it says that I have this many to choose from. A, B, C, D, and E. So that's 1, 2, 3, 4, 5 choices. That's my N. So in this first spot, there are 5 letters I could get. I could put A, B, C, D, or E. But I'm not allowed to repeat. So for this spot, there are only 4 letters left to choose from. And for this spot, there are only 3 letters left to choose from. So 5 times 4 is 20, and 20 times 3 is 60. Okay? Or, because it says not repeating, you can go do your permutation. So 5 permutation of 3. So we're going to have 5. And I go over to my math button. I go to probability. And I have 3. Hey, we get 60 again. Again, it's just a preference, which one you want to use. All right, so 41 is a little different, so I'm going to do 41 with you. 41 says, stocks on the New York Stock Exchange companies whose stocks are listed on the New York stock have their company names represented by either 1, 2, or 3 letters. Repetition of letters is allowed. What is the maximum number of companies that can be listed on the New York Stock Exchange? So you have to do these one at a time. So if they only use one letter, only used just one, then I have 26 different things I could do. Okay. If they choose to represent their company with 2 letters, then I have 26 to choose from and another 26 to choose from because repetition is allowed. So this is if they choose to do it with just 1. This is if they choose to do it with 2 letters. They also have a choice of using 3 letters. Well, if I choose 3 letters, I still get 26 letters in the alphabet here, 26 here, and 26 here. So what you're going to do is you're going to take each one of these and add them up. So we're going to type that in the calculator, and we get 26 plus parentheses 26 times 26 plus 26 times 26 times 26. And that tells me that I have 18,278 different arrangements, whether it be with 1 letter, 2 letters, or 3 letters, whatever the company chooses. All right, let's go look at 43. So 43, the very first thing I see right off the bat is it uses the word committees. And when I see the word committees, I'm going to think about the C button in my calculator, about combinations. And it wants to know how many committees of 4 students can be formed from a pool of 7. All right, so this is the number of people in the committee. And it's how many I have to choose from. So this is my N, and this is my R. So I'm going to have 7, choose 4. I want to know how many combinations. So I have 7 total people to choose from, and I want to know how many combinations I can get if I'm going to pick 4 out. So it says I'm going to have 35 combinations. All right, let's go look at 45. 45. How many arrangements of answers are possible for a true-false test with 10 questions? Okay, so question number 1, there's 2 possibilities. Question number 2, there's 2 possibilities. Question number 3, there's 2 possibilities. And this is going to go on and on and on until I get to question number 10, which is still going to have 2 possibilities. So how many times is the number 2 going to be written up here? Well, hopefully you can see the pattern. It's going to be 2 to the 10th power. 2 times 2 times 2 times 2, 10 times. So if I put that in my calculator, I get 1,124. Okay, let's go to 47. A 4-digit number. How many 4-digit numbers can be formed using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 if the first digit cannot be 0? Repeated digits are allowed. Alright, so I'm going to set this one up. I want a 4-digit number, so 1, 2, 3, 4. So it says the first digit cannot be 0. That means I have 1, 2, 3, 4, 5, 6, 7, 8, 9 different numbers that it could be. It could be 1, it could be 2, it could be 3, it could be 4, 5, 6, 7, 8, or 9. Now, for these last 3 digits, I can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which means there are 10 numbers it could be. And it says that I can repeat. So I still have 10 numbers to choose from here, and I still have 10 numbers to choose from there. So you're just going to go multiply 9 times 10 times 10 times 10. You're going to have 9,000 different arrangements. Okay, I'm going to let 49 be a homework problem, but there is a typo where it says 4 different mathematics books. This should be 5. So make sure that you make that correction. I'm going to let you do 51 also. I think you can handle that one. This is a lot like the menu problem. Okay, 53 is the birthday problem. We did one like this in our notes on the front, so why don't you try 53 also. 55, I think you can do that one also. It's a committee problem, just like number 43, and I'm going to get rid of number 57. Okay, so let's recap what we did and what you still need to do. So on the front, you still need to go do 9 and 13. I got rid of 11 and 12. You need to go do 17 and 19. I got rid of 20 and 21. Number 23 we did together. I want you to go do number 25 and find how many. We did 27 together. You're going to do 29. Find how many. We did 31. You're going to go do 33. We did 35 together. You're going to go do 37. I did 39 with you, and I did 41 with you. We did 43 together. We did 45 together. 47 together. I asked you to go do 49, 51, 53, and 55, and I got rid of 57. Alright, so you should be able to complete the rest of this worksheet. Once you've completed it, check it with a friend of yours and see if you have the same answers. Ask me questions if you have any, and when you're ready, you need to take the quiz that is right after this video. Alright, let me know if you have any questions.